Hello, this is Mr. Anderson for Kellogg Community College, and we're going to be looking at a specific homework problem. This is for Math 121 Intermediate Algebra. We're going to be looking at Chapter 6, Section 4, or as I like to call it, 6.4, problem number 57. The goal of problem 57 is to solve for x, and on the left-hand side we have x squared plus 2x plus 1 under 1, and then we have x minus 1 over 3x plus 3, and then we have x plus 2 over 5x plus 5. Now my goal here is to clear the denominator, and what I will do first is underneath each of these denominators here, I'm going to factor them. This will help me find out what the number or numbers I need to multiply by to clear the denominator will be. The two numbers that multiply to make 1 and add to make 2 is x plus 1 and x plus 1. Now over here I can factor out a 3, and this would be x plus 1. And here I can factor out a 5, and that would leave me with x plus 1. This means my common denominator for the entire problem is going to be x plus 1, and 15. Because I notice that this first fraction here has two x plus 1s but doesn't have a 3 or a 5. So I'm going to multiply this blue fraction by 15 x plus 1, x plus 1. This has only one x plus 1 but has a 3. So again I'm going to multiply this by 15 x plus 1, x plus 1. I'm going to multiply this by 15 x plus 1, x plus 1, because that is going to make sure that things cancel out, and since I multiply each one of these by the same thing, the 15 x plus 1, x plus 1, I'm not violating any rules of algebra. Anything you do on one side of the equation, you have to do on the other. Now what I'm going to do is I'm going to rewrite my blue fractions here, but I'm going to rewrite my blue fractions with the factored form in the denominator. So this is going to be 1 over x plus 1 twice, or x plus 1 quantity squared. It doesn't do me any good to actually put this back together since I'm going to be simplifying things in red. This is going to be x minus 1 over, and in this case this is going to be 3 and x plus 1. And this is going to be x plus 2 over 5 and x plus 1. Now, as I said, I'm going to multiply everything here by 15x plus 1, x plus 1. So I'm going to change colors again and show you that every single thing is going to get multiplied by the 15 x plus 1, x plus 1, 15 x plus 1, x plus 1. And we did this in class, and I wanted you to recall, I call these balloons, because when we have a common balloon on top and bottom, we're going to pop the balloons or simplify them to make 1. So for example, these simplify. I know you would say cancel, but technically dividing by itself isn't really canceling, it's dividing, it's making 1. So this fraction over here is 15 times 1, or just 15. Now this simplifies with the x plus 1, and 15 divided by 3 is 5. Which leaves me with, in the numerator here, 5 times the quantity of x plus 1, x minus 1. Now over here, I have the x plus 1 simplify again, and 15 divided by 5 is 3, which leaves me with 3 times x plus 2 and x plus 1. Now what I'm going to do to simplify my right-hand side a little bit is I'm going to FOIL these that are next to each other. Now, you could distribute the 5 and the 3, but you would only do it to the first set of parentheses. I prefer to FOIL and then distribute the 5 throughout the trinomial and do the same thing for the 3. So in this color, I will show you the FOIL process. So this is going to be 5 times x squared minus x plus x minus 1. That's the FOIL of these two binomials. Plus 3 times x squared plus x plus 2x plus 2. equals 15. Now, what I'm going to do in the next step here is in the green step, I'm going to simplify these trinomials. So 15 is equal to 5, and then this will be x squared minus 1 plus 3, and then in this set of parentheses here, we're going to have x squared plus 3x plus 2. So now the next thing we need to do is distribute the 5 to this binomial and distribute this 3 to this trinomial. I'm going to change colors again so you can keep track of each of the different steps here. And I'm going to go to a light blue here. So my 15 is equal to 5x squared minus 5. And this is going to be 3x squared plus 9x plus 6. Combining all of these terms together in the next step here, whoops, there we go, I'm going to have 8x, and then the 9x, and then the plus 1. I'll bring the 15 over to this side, and now I have 0 equals 8x squared plus 9x minus 14. And I made a little error up here because this is 3 times, 3 times 2 makes 6 here, and then 6 minus 5 is 1. If I take the 15 and subtract the 15 here, I do get minus 14. So I forgot to show the step of me subtracting the 15 from both sides, but that's how I get the 14 there. Now the question is this factorable? And the answer is yes. So I'm going to spend the next slide showing you how this can be factorable. So let me quickly clear the screen and go to a new color here. I will choose, let's see, black. So what we left off with in the previous problem was 8x squared plus 9x minus 14, and that was equal to 0. We can use the symmetric property to put the 0 in either place, but it doesn't really matter. So now the question is how do I factor this? Well, from my class, you learned to multiply the first and the last number together, which gives you negative 112. Now, our job is to list all the ways that we can divide to make negative 112 or factor it, and our goal is to get to 9. So, obviously, 1 and 112 is one of the ways, but this would give you negative or positive 111, which isn't the positive 9 there. So, what we need to do is try 2, and 112 divided by 2 is 56. Now, making sure one of these is negative, this is going to either give us 54 or it's going to give us negative 54, so that's not going to work. Our next workable, 3 doesn't divide 112 easily, so 4 does, and 4 and 28. Unfortunately, this only gives us 24 and negative 24, and then we try a wild card, the number 7, and it actually works. 7 and 16, and lo and behold, if I use a negative 7 and a positive 16, I get my number of 9. So I break this 9 into a negative 7x and a positive 16x. And then I turn this trinomial into 4-term polynomial. The 4-term polynomial can then be factored using the grouping method. So this becomes an x factored out, so this is 8x minus 7. And in the next two parts here, we can factor out a 2, which leaves me with 8x minus 7. And from our grouping method, we have the binomial that matches gets written once, and the terms left over get written once themselves. And if you FOIL that out, you would see that it does make this trinomial up here. And then what we do is solve for x. 8x minus 7 equals 0. X plus 2 equals 0. So I'm going to add 7 to both sides. 8x is equal to 7. So x is equal to 7/8, which is one of my two answers. And the other problem, I'm going to subtract 2 from both sides. So x is equal to negative 2. This is another one of my answers. Because our danger numbers, or our numbers that would have turned the problem into division of 0 error, was negative 1. So since -1 is not one of our two answers, we can accept both answers as possibilities for the problem. Thank you for watching.